Alright, draft science video. Yay! I've been watching some Feynman lectures and interviews. This Pyro seems to have a great deal of respect or whatever. I had an impression of him from the past watching interviews, and he's a likable enough guy. And he says some things that are nice things to say. Curious mind and all that stuff. But I gotta say, he is sort of irritatingly hypocritical. In some things he just kind of says, oh, we should have to just accept it. And then other things he say, no, we have to keep chasing this. There's a truth here. Let's find the truth. It just doesn't make much sense. And that was sort of my impression watching a fairly old, had to be the 50s, I guess, lecture he did outlining the two-hole experiment, as he called it. And I was kind of stunned by how he didn't talk about how science or even himself would see a need to resolve the mystery, to find out why. How exactly does a photon or an electron interfere with itself or with some other electron that might have passed, a year ago? And that seems a really good question to ask, because that's the apparent circumstance. And I think it's worth trying to understand why the experiment looks that way. So then it gets into this whole uncertainty principle, and I guess he did okay on that. He didn't imply that it was some sort of law, that it was just the idea that, we're confronted with a problem. You can't observe things that are outside the realm of our scalpel, outside the realm of too small to be interfered with. And so he sort of made that part clear in the two-slit experiment, that it isn't so much that gross interference is unacceptable, it's that any interference somehow destroys this wave pattern, this idea that the particles are waves, or have a wave constituent. Any interference. Any. Any. It just doesn't, and that part is what sort of reveals that there's an answer here. And all we need is, somebody with the energy to pursue it. And it seems kind of disappointing that since 1950, nobody's had that energy. Damn it. But there is an answer, I think, quite clearly. So anyway, and I think it's in the instrumentality, but whatever, that we're using to observe or to conduct the experiment. The experiment is not revealing a truth. It's revealing an aberration of the instrumentality we're using to look at the truth. So that's what this video will be about, I guess. Let me see, I wrote down a couple of things, but the idea, I guess, is sort of to make arguments. I like the idea of lectures. I like the idea of presenting an argument and see if other people can present some other counter argument and point out where that won't work or this won't work. And it seems there needs to be a lot more of that. It's kind of startling to think that this stuff has been argued, to some extent argued anyway. I don't know, there seems to be an awful lot of physicists who are pretty damn comfortable just sitting on a very mushy foundation, kind of soggy, wet diapers. I don't know what the hell it is. It seems glaring that something that so much physics is based on, that this would be scrutinized hard and completely and thoroughly. But for whatever, almost 100 years, we're just leaving this sitting there. So anyway, all right, my argument's going to be about this wavelength thing again, and this whole idea of this transition from electron to photon. Are they the same thing? Electrons create radio waves. Electrons can create heat, but maybe they radiate it. The spectrum of energy, or frequency, it goes from this, whatever, zero number to, gazillion, bazillion hertz or whatever. I don't know what kind of frequency gamma rays are at, but, it's way up there. But I was thinking of it in terms of, this two-slit experiment. So, because they have this problem. Well, if you look to see what slit the photon goes through, you destroy the wave pattern effect. So, well, why don't you just make sure what slit you fire the photon through, or the electron? Then you don't have to figure it out later, do you? If you know ahead of time that your gun is reliable and that you fired it through the slit. So that was part of the setup here. Is that, well, here you have an experiment where you say, well, let's not fire electrons straight. Let's fire them crooked. Let's fire them eccentrically, and only watch what the eccentric ones do. Basically, because that's what the two-slit experiment basically does, is wipe out any directly fired electrons, any straight liners. It's only going to view the crooked liners. So to me, that basically is saying that we're only going to accept results from specific types of electrons or photons. That there is a definition. You are narrowing the subject being studied now all photons will not be allowed, all electrons will not be studied. Only a certain type is going to be observed through this experiment. So that should tell us something right there. But anyway, I was thinking about, like I said, I'm interested in how an electron or a photon carries its frequency is not the only word I'm looking for. But anyway, the frequency component, there's a word for it now, I can't think of it. The simple word, maybe I wrote it down. This is a simple word. Not velocity. Well, it doesn't matter. All right, so let's say, different light has different frequencies. Like I said, you go down the spectrum, you get the infrared, you go lower, you get radio waves, and go higher, you get ultraviolet light and microwaves, and whatever's after that, and blah, blah, blah. And that's the electromagnetic spectrum. But I'm thinking in terms of, again, I don't think electrons are flying through space going like this, doing a sine wave. That's how we visualize, that's how we interpret when we, throw something through an oscilloscope that's intended to be a translator. It's intended to turn something we can't see into something we can see, and that's how it interprets it in this flat, one-dimensional wave pattern. And that seems kind of silly. So we need a better imagery. So you could say, okay, you could redraw it as some sort of, widening and then narrowing and then widening, then narrowing and widening kind of blob, fog, or wave, as Pyro would like. But that sort of just blows up the whole particle theory, because it's no longer about a particle, it's about some energy it's possessing, some gravitational field or some other component that can't be dissected. But yet it interacts as if the whole wave space, the whole influence space was the particle. So my take on it is just to think of, what the hell? That's still recording. Why did it beep? I heard it beep. I don't know. Anyway, the video's getting long already. I was going to try to make these short. That ain't going to happen. So anyway, I was thinking more like a screw. That the electron or photon reveals its frequency by having an eccentric orbit, and that that's how it stores a momentum beyond its speed of light. Excuse me. Because not only does it have forward motion, but it has this hidden motion of its own orbit. So, like the Earth revolving around the sun, it has one kind of, that's probably a bad example. I'll have to think about that. But connecting it to a gravitational thing, there's not only the fact that the photon is moving forward through space, okay, at the speed of light, but that it's in fact going faster than the speed of light because it's also rotating within that, let me see, it's also traversing more distance through that rotation. So maybe it's still going the speed of light, and then the thing that changes is how wide or narrow that rotation is. The point I wanted to make, though, is that you would have kind of a double impact for the photon. You'd have not only its mass, whatever that might be, which seems like it should be something like 1, like all the same, like nothing, and that the component that's really carrying the force of the photon is completely dependent on how tight that spiral is, how quickly, as a component of distance, it does a complete cycle, a complete spin around that center. So I think there's been some illustrations of that, and people just poop on stuff and say, oh, that doesn't work, oh, that doesn't work, or some other kind of thing, kind of cavalierly. But I think if you add that kind of motion, you can explain frequency, which is, it's just it's just so much part of the game, because that's where photons acquire their peculiarity, and that's where they have the potential to affect matter differently. And that's why you would have ultraviolet light reflect off of a plant, say, and have other energies, other frequencies of light be absorbed and converted for photosynthesis. Because there's a different thing, you need different mechanisms to appreciate that movement. And at a higher frequency, you won't be able to make anything out of the noise. It'll vibrate too quickly or something, vibrate beyond the means or the mechanics of the thing that you're attempting to interpret. I didn't say that right. It doesn't really matter. This isn't a lecture. This is a draft science video. I will label the lectures lectures. With those, hopefully, I will be more concise and make the argument really clear and explicit. So I guess I will give up here on this subject and just say, yeah, well, I'm going to talk about this shit, and we'll see if somebody else wants to talk about it, and maybe we can resolve this whole unification of the, electromagnetic spectrum thingy. It is curious. I mean, it does seem there should be connections in how forces. I mean, it's like gravity. Gravity affects every single little speck in the universe, and it just seems like you have to come up with an explanation for that. What's the mechanism that creates that appearance of attraction or repulsion? And just obviously we don't see any electricity shooting back and forth between solar systems or galaxies. There's no energy transfer taking place. So it does obviously seem a very different mechanism than the mechanisms operating on the small scale. Anyway, I'm going to talk about it. And so until next time, and blah, blah, blah. Okay.